Hello, good evening, everyone. Hi, can you hear me? Okay, great. So I've uploaded the project presentation order. So basically, you will know the order that you are going to present, although we cannot fix the time that you are going to present. Yeah, so first I would like to check whether the group 1, Yuan Yan, Wang Ting Long, Lai Wing Yi, Lo Chung Ta. Are you guys there? Please turn on your video and share your PowerPoint slides. Yeah. So first, I would like to invite the group number 1 due to Lai Wing Yi's request. The group wants to make presentation today, and yeah, so I actually make it number 1 to present. Okay. So there's some noise. So someone, yeah, please mute yourself. I guess Yuan Yan, yeah, your place has big noise. You are working, you are staying at some machining room or? Okay, so please start your presentation if you guys are okay.
So, can you hear me right now, Professor?
Yes.
So, and other group mates, please mute yourself first. Okay, thank you. So, let's start our Q&A presentation. So, hello everyone. So, today we are going to present our research, which is the coincidence in TX, which is the tests and the related factors. Next. So, first of all, here is our contents and outline of today's presentations. We will briefly present the background and objective of our research. After that, we will describe about our data set, which we selected. Next, we will use our three tools, which is the Writer, Python, and the R language. The results will be presented in the following sections. Last, the insights, suggestions, and conclusion will be drawn. Next. So in recent years, the car accidents caused a huge death and cost in the US. The US government seems to spend a large expenditure in the car accidents. According to the data by ASILT, there are around 4 million people dead in car crash. Moreover, those car accidents cost more than 1,200 million of US dollar each year, including the medical costs and the repair costs. Therefore, we developed a research which focuses on the factors and their variables, and we want to find out which variables are most related to the series of car accidents. Different methods will be used and compare the results. Insights will be drawn in the last sections. Next. So for the data set we selected was included for 14 lines based in USA, but we selected TX as our study focus. The reasons of choosing TX is because we want to develop a more focused research, and TX is the second high of car accident in US. The data sets include different factors and different car accidents. The data sets also describe about the car accidents, and those data were being recorded between February of 2016 and December of 2020. And here is the hyperlink. Next. So now I'll briefly talk about the data in the data set. First of all, the car accidents. The data set recorded 53,799 car accidents and divided into 4 levels. The percentage of the severity and plus car accidents were shown in the pie chart. Most of the car accidents were defined as level 2. Next. So in the data set, there were 44 variables were recorded. For example, crossing, traffic signal, and junction. Those variables would be used to find out the relationship among the factors and the level of the car accidents. In the pie chart, it showed that in most of the car accidents happened in a situation which did not have the crossing near the car accidents. Next. From above graph, it recorded that most of the accidents happened in the place which have the traffic lights and junction. Those 2 variables can be considered as the variables which increase the number of the car accidents. Next. So for 2, we used features which the weaker Python and the R language. So now I'll pass the time to my group mate to talk about the results of these 2.
Thank you. Using the WICA, we are trying to construct a decision with 3 approaches to separate the data set. The 3 approaches include only atmospheric effect on severity of traffic accident, only traffic facility on severity of traffic accident, both atmospheric effect and traffic facility on severity of traffic accident. The tenfold cross validation method is used for separation of the training data and test data. Next. For only atmospheric parameter effect on severity of traffic accident, temperature, humidity, visibility, and wind speed are used as parameter. These parameters are in continuous and is divided into 3 ranges for analysis. However, it could be seen that only one lives in the decision trees. Next. Similar situation occur for only traffic facilities. Then, next page. A better result could be a better tree shake could be seen only when both traffic facility and temperature parameter are included. Next. This is the tree. Okay, next. However, it could seem that all the 3 decision trees have high error rate, more than 90% error. Therefore, although the decision tree could be drawn, no clear relationship between severity with the atmospheric parameter and traffic facility could be concluded. This may be caused by uneven number of different range of the parameter. Next. The following graph shows the severity distribution over different parameters. However, it is shown that the graph in this way unable to show the relationship of severity and the other parameter. Our other group mate in later slide would have other graphical interpretation. Next. Sorry. Oh, next. Okay. The reason may be uneven distribution of different range in one type of data. For example, the number of level 2 in severity is much higher than the other range. Actually, if same number of level 1 to 4 is extracted from the original data set and put in the WICA for construction of decision tree, the relative absolute error is reduced. Then I pass to my other group mate to talk about other methods.
Thank you, June. Additional to WICA, we also try to use Python to draw relationship or conclusion. Next page. At the very beginning, data cleaning is essential before the act of visualization. We remove 7 columns, which are not related to our focus of today's topic. Also, I removed some rows with missing value. As such, the data size dropped more than 18,000 and only around 35,500 left. Next is, by plotting a pie chart, we could see the distribution of severity. It is obvious that level 2 of severity took the majority, then following by level 3, 4, and 1. After that, we try to study the data set in 4 approaches. Next, please. First of all, the correlation of severity and other variables like visibility, temperature, or junction, etc., as well as in this diagram. However, no obvious relations could be observed, as most of the colors tend to be red across the first row. Next, please. Then, with the help of bar charts, we could see the distribution of accidents by hour. Most of them are at midnight, the time people become less conscious, and also the peak hour during office going time. Next, please. Again, by plotting a pie chart, we could see the distribution of accidents by different day of the week. The number 1 represents Monday, and number 2 represents Tuesday, and so on. We could see that they are quite evenly distributed, while we first detect to see more accidents on Saturday and Sundays, which are the days with more holiday drivers. Next, please. Lastly, by plotting our bar chart, we try to observe the relation of weather conditions and accidents. However, as you could see in this diagram, most of the accidents happen on bad days, not on foggy, rainy, or snowy days as we first detected. Now let me pass the time to Dustin to share our result of R.
After having data visualization on week curve by the quantity of accident in different severity level in various conditions, including the weather and road conditions, then we tried to use Python for further information about the correlation and more study on the accident data of the date and time relationship. Now we are trying to use our language to understand more if there are any conditions leading the accident to different direction on the severity level by proportional static bar chart. The first condition we can find out the relationship on the severity level is the traffic signal. You can see the white color on the graph labeled as true, showing the accident are happened nearby a traffic signal, and the black color labeled as false, showing the accident are happened at the location without traffic signal. And we can see once the accident are nearby a traffic signal, the severity level tends to be lower, which are level 1 and level 2. However, we can find a totally different result by plotting another proportional static bar chart with junction. We can see the white color on the graph labeled as true, showing the accident are happened nearby junction, and the black color labeled as false, showing the accident are happened at the location without junction. And we can see once the accident are nearby junction, the severity tends to be higher, which are level 3 and level 4. To conclude, although we do not have enough evidence showing any relationship between weather and severity level of accident, we find that there are more accidents happened during midnight and also off-work hours, like around 5 p.m. to 7 p.m. So we suggest the Texas government to reserve and assign more resources to stand by during the mentioned period of time in order to handle the accident in a better way and faster response time. Also, according to the relationship found on both the junction and severity level, traffic signal and severity level, for those traffic backposts with junction, the Texas government can consider adding traffic signal there in order to lower the severity level once accident happens. And this is the end of our presentation. Thank you.
Okay, thank you for group number 1. Very interesting insights, very detailed analytics. And I guess due to the time constraint, so I probably will skip the question session. So let's directly move to group 2. Thank you, group 1. Siu Hua, Choi Shen Xing, and Ho Lai Tun. Yes, please.
Hello, can you see my screen?
Yes, and I can also hear your voice.
Good evening, everyone. Our topic is evaluate the demographic structure against housing transaction data. Housing problem in Hong Kong is a very serious problem. Housing supply is insufficient and short supply and property prices are very expensive. Although housing problem has caused social controversy and discussion, there are few solutions that are useful. It is not enough to address the problem. Therefore, this project hopes to analyze the future trend of housing demand in Hong Kong based on the population and land structure by different models. Before we give a solution to solve the problem, let us take a look at the data set we used. Our data set is come from CenterMed, which is collaboration between Hong Kong Centerline Property and the Lands Department of Hong Kong government. In our data set, we have 175 variables. As there are too many variables, so I just introduce some important feature. In our data set, we have location, that is the different district in Hong Kong. And we also have the Hong Kong resident population to show how many people live in Hong Kong. And we have the age structure from different age and the educational attainment, the household size, monthly domestic household income, secondary sales by instrument dates. Here are some visualization that we get from the data set. In Hong Kong, there is about 7 million population. From this graph, we can see that the population between 14 to 64 years old is the largest, about 14%. Also, we can see that people mainly age 15 to 64, they are all qualified to work. From this figure, it shows that most people graduate from high school. And in this graph, it shows that the household size is 1 to 3 members, accounting for 17%. In this graph, we can see that the household income in Wan Chai and Central and Western are higher than other districts. We can see the two peaks on the red line. This map shows that the transaction volume in Kowloon City and the Eastern are the highest. We can see that the blue color is the darkest. That means we have more transaction volume. This map shows the average unit price in the Central and Western is obviously the highest as the color is the darkest. And then my groupmate will going to talk about the other part. Thank you.
Thank you, Alice. Can you guys all hear me? I assume it will be yes. So after visualizing the data set, we would like to look for some insights from existing literatures, and we have identified this piece, which looks quite relevant to our research. Next page, please. So this research article was written by 4 researchers from Chongqing and Zhejiang University back in 2019, which studies the effect of demographics on housing consumptions in China using data from 31 provinces so as to make a better forecast on the housing demand. So they have applied the regressions over a time series of data from 1999 to 2017. And the below is a snapshot of the regressions model they have done. Next page, please. So this slide shows a table of the model variables that they have used in the paper. The top one, HSA, housing sales area, is the dependent variables, whereas the others are all independent variables. So how do we adopt this framework to our analysis? Can we move to the next page? So the article is using a demographic data from 31 provinces in China. In our case, we'll look at the demographic structures at the sub-district level, like Kowloon Tong, Central, Causeway Bay, to see if they have any relationship with the housing transactions within that particular sub-districts. And of course, we do need to make adjustment for data limitations. For example, since the demographic data in Hong Kong are updated only every 5 years, and the last update was back in 2016. So for this exercise, we decided to focus on just one single snapshot of demographic structures as of 2016 and examine its influence on the transaction activities in the subsequent year, which is 2017. We've also removed and modified the definitions of different variables given the unavailability and inapplicabilities of some data, resulting in a regression model of 6 independent variables, which includes income, population, child age dependency rate, which is CDR, old age dependency rate, which is ODR, family size, and education. So let's look at the regression result. Next slide, please. So based on this regression result, we see that only population, CDR, and education are statistically significant at a 5% level. In terms of adjusted R-square, our model yields a R-square of 0.6 versus a 0.91 in the literature. So we can see that there's a lack of explanatory power. If we compare the results with the model, next slide, please, we can see two main differences. Household income is significant in the literature, but not in our model. And this is and for population, this is exactly the opposite case, which we see significance in our model, but not in their literature. Next page, please. If we do a feature selections with the objective to maximize the adjusted R-squared, then in that case, population, CDL, family size, educations will all be selected into the model, although family size is not a significant variables based on the results. The resulting adjusted R-square is just slightly higher than the original model. So we see that the feature selection doesn't give us a lot of improvement. Next page, please. In view of the not very satisfactory explanatory power of the model, we tried a few more modifications to see if these modifications can improve the results. The first one that we try is to add a proxy to the housing completing area. Next page, please. Which we do not have the data at a sub-district level. So we do make some proxy for that and put it into the model. It turns out that the variable itself is only significant at a 10% level, but not at a 5% level, although the resulting adjusted R-square is marginally better. Next page. We also tried adding a variable for property price because intuitively we will imagine that a cheaper property price should drive a larger demand for the housing properties, but it turns out that it is not significant as well. Next page, please. In Hong Kong, children are more likely to get admitted to primary schools within the school net that overlaps with the districts that they are living in. So some districts with renowned primary schools are particularly popular among parents, and we try to incorporate this into the equations. But again, they turn out to be not very significant at a 5% level. Next page, please. The last one is a more exploratory in nature. Since demographic data in Hong Kong is available only every 5 years, it really does not give much insights if we could only use this demographic data to forecast the transaction activities in the next year. So we try to see if there are any relationship between this and the medium-term transaction activities. So we here in this new model, we replace this annual sales area of 2017 with an aggregate sales area from 2017 to 2020 as dependent variable. So under this new model, CDR is no longer significant, but the adjusted R-square is much higher at a level of 0.644 versus 0.6. It might mean that demographic data has more predictive power for a longer term, and it could be something that we can look into if we are doing the follow-up for this project. That's the part for the literature review, and I will pass the time to Kathy. Can you please move to page? Yeah, 2 more page. Thank you.
Thank you. So because even though we find very good literature, we try to replicate it, but it doesn't look so very good result. So, but we are very happy with the data set because I think we think this data set should give a very insightful analysis on predicting the housing demand. So we move further to apply different model to do 2 types of prediction. One is we want to predict the secondary housing price, Another one is to predict the secondary housing transaction volume. So these two, we believe these two analysis or these two predictions should give a very good indication on how the future housing planning can be done. So next slide, please. On the data set, we are using 172 observation based on different areas, and the predictors will be 124. We believe all these predicted the demographic data collected in the census and also the properties data by the centerline property. It should give a very good insight. Next slide, please. So we have tried to plug in these data sets to do two types of prediction. And here I give a brief outline on the predicting the housing price here. So here the linear regression, even though the adjusted R-square kind of looks really good, but the p-values for most of the predictors, they are not statistically significant. And even the RMSE is really not good. Next slide, please. Later on, I will tell the reason why we find this result. And we also apply the Rich and Lasso regression, and the RMSE this time looks better, but even though it is a lot better than the linear regression, the RMSE isn't really a good indicator on the error is it looks quite big in terms of when we want to predict the housing price. Next slide, please. And we apply the support vector regression also, and also even not a very good result. Next slide, please. And also the tree-based models. And for the random forest, we highlighted it looks a little bit better, but still not very good. Next one, please. So here is a summary. For the second, the first column, the secondary sales price, it is a summary of the previous results, RMSE on the various models. And the last column, these are the predicting the secondary sales transaction volume. As you can see, in this monthly volume, the RMSE is still about 3 point something error. So we are not really happy with this result, even though some of these models looks comparatively perform better than others. Next one, please. So here is a conclusion and recommendation. Before I jump to the conclusion, previously I have mentioned that the p-value isn't very good, not statistically significant. I try to, when I run the linear regression model, I try to play around with these predictor by selecting or deselecting all these predictor and try to get a better result in terms of the adjusted R-square. But at the end, we find that even we try to deselect or select these predictors, it ends up having a really small amount of predictors. But we truly believe that these predictors, they should give a really good insight, because when we assess the housing demand, the demographic data, people's data should be kind of indicative, or should have certain correlation on that. And when we try to play around with this model, what we interpret about why the result isn't really good is that the N is too low. Because when we try to assess the do the data processing, even the number of region that we use is 172, and end up some region it does not have really any transaction data, because this is just monthly transaction data. So, and even though we use all the N here, all the observation here, the N is still too low. And also for the census data, these are just once in a 5 years of census data collection exercise. So historical data might not necessarily equal to the present demand. And also all these are just monthly transaction data. So, but we try to collect more data from the census and also the center line. but it seems we try to expand the N, but end up you can't find a better data sources. So what we recommend is if there is further data sources which allow us to get access to individual or having more observation data, especially in terms of the individual demographic data instead of regional data, then that is in one case that will expand the N, and the other case that can be more apple to apple instead of have a summarized data in terms of the regional data set. So yeah, that's the end of our presentation. Thank you.
Okay, thank you very much for the group 2. So very rich experience on playing with linear regression model. Yeah, so next let's move to group 3. 顾文斌、郑宇生、张一鸣、姚于静. Yeah.
Hi, can you see my shared screen?
Yes. Also, I can hear the voice. Yeah. Please start your presentation.
Okay. Good evening. Here are the contents of our presentation. Our presentation is divided into 4 parts: introduction, data analysis, price modeling, and the conclusion. In this presentation, we are going to share our practice on data analysis about the information of Airbnb's room sources in New York. Airbnb is a rental housing website which founded in 2008. It dedicates itself to connect tourists and homeowners who have available rooms for rent and offer a variety of accommodation. Over the 13-year period, Airbnb has rapidly become a short-term rental homestay industry giant. Nowadays, it still impacts on the traditional hotel industry and keeps expanding. Our research focuses on Airbnb's publicly available data sets on Kaggle, with the aim of analyzing and virtualizing information on house location, types, and prices in New York. The variables in the data sets including neighborhood, home type, price, and number of reviews, latitude and longitude, and so on. Our research objective is to identify the critical factors that have a significant influence on housing prices and provide a reasonable price as a reference to those new homeowners who want to release their rooms for renting. We hope this data analysis could optimize the experience for users on Airbnb and promote smart tourism. And before we analyze the data set, some preparations like data pre-processing have been done to ensure the quality and accuracy of our research. We deleted the useless column and the missing value and renumber each house resource. We employed Python and Tableau as the analysis instrument to make visual and geospatial analysis, and established price model to predict housing prices. Now I will introduce my groupmate to make virtual analysis.
Okay, thank you. Hi everyone, my name is Zhang Yiming. I will introduce the second part, data analysis, with my teammates. Next. So firstly, we found the dataset of New York Airbnb in a Kaggle database, processed over 40,000 data. And then we use Python and Tableau to perform visualization and geospatial analysis. Next. So I use Python and Pandas to generate the basic visualization. Firstly, I import profiling to have an overview of our data. And you can see that there is no missing cells, which means we already cleaned this data set. And we can also get the correlation between these general variables. We can find that there is no very strong correlation between them. So these different general variables are not overlapped. Next. And then I import a bar chart from PRE chart to generate the visualization of numbers. We can see that Manhattan has the highest number of rooms, while Brooklyn has the highest number of reviews. And if we compare these two charts, we can see that for numbers of rooms or reviews, the situation in these two places is not particularly different. Next. And from the perspective of price, I use mean function to get the mean price of different types of rooms and the mean price in different regions. We found that entire homes are most expensive, and the room price in Manhattan is the highest. Besides, we can see that the price difference in room types is more obvious. Next. And I also imported two kinds of pie charts to generate the visualization of a percentage. We can find that the proportion of rooms priced between $50 and $100 per night is the largest, and the percentage of the number of entire home is the highest. Next. Okay, that's all my parts. The next part will be introduced by my teammate Gu Wenbing. Thank you.
Hello everyone, my name is Gu Wenbing, and in the next we use Tableau to do the geospatial analysis. So look at this picture, we can see the distribution of Airbnb listing in the 5 districts of New York. It is clear that Staten Island has the least distribution of listing, and we speculate that it may be because the area is not close to the city center and the transportation is relatively inconvenient. And Queens and Brooklyn have a similar number of housing sources, but Queens is a little more widespread. Next, please. And in this picture, we did a geospatial analysis of the room types as well. The 3 room types were found to be very unevenly distributed in the New York area. It is clear from the graph that entire room account for the most of all listing. And the number of private rooms also distributed throughout the 5 districts is far less than the number of entire homes, and the least number of shared rooms are found in the southern part of New York in Brooklyn. Next, please. And this picture, we can see from this graph that Manhattan has the highest average price at $197, and the Bronx has the lowest average price at $87.8. Brooklyn and Staten Island both have an average price of almost $120, while the average price in Queens fluctuates around $100. Just we can see that the price of a property is not directly related to the density of the properties. Even though Staten Island has the lowest number of properties, its average price is in the middle of the 5 regions, while the highest number of properties in Queens does not mean that it has a high average. So this is the end of the part 2, and in the part 3, we do the price modeling and welcome my group member Yao to do the instruction. Thank you.
Okay, in this part, I will introduce the price prediction model. First, see the predictors as shown. We drop the ID, name, host ID, host name, last review column, since it should have no effect on the price. And some values like price, which is not a number in our data, so we are replace them with 0. And we drop the rental listing with price 0 because we don't care why these rooms are free. And drop the latitude and longitude columns since they are hardly of any use in our regression. And we think this feature is highly correlated with neighborhood group. Next page. In our data, some columns have labels, so we use one hard coding to turn it into numeric variable. As shown in the 2 tables, the neighborhood group only have 5 values and the room type only have 3 different labels. So we encode them here and drop the original columns from table. And we also drop the neighborhood column. Next page. And now we can do the prediction. Along with linear regression, I use lasso regression and random forest regression for price prediction and use RMSE to compare the model's performance. But we keep getting very large RMSE, which can over $15 when finish the prediction using testing set. And we found out that a lot of our data was super skewed to left, and the tail end of the skews were acting as outliers and pulling our predictions one way. So we use log transformation to solve this problem and make the inclined distribution close to the normal distribution. So we log transform all our data as the table show, and it ended up working. Next page. We split the data set into training set and the testing set and feed the model to the training data set. From the result, we can find some large coefficients, and their corresponding feature attributes are entire home, shared room, and Manhattan. So the room type and whether it is in Manhattan are the biggest factors affecting the price. Next page. Get predictions on the testing set and use 10-fold cross-validation to confirm the accuracy of the RMSE. And the average value of the correct rate or error rate of the results of 10 times is used as an estimate of the accuracy of the algorithm. The figure below shows the test results. The RMSE is greatly reduced compared to the value before the log transformation is used. Okay, next page. And we also use lasso regression and the random forest regression to predict the price, and use 10-fold cross-validation to confirm the accuracy of the RMSE. Here are the results. And we find that the linear regression has the best performance. Next page. And at least we also do some classification work and try to recommend a suitable price range for people who want to conduct a short-term rental business, which is also the majority of the types of listing in the data. And we divide the price into 3 levels, high, middle, and low. And we use logistic regression, random forest, decision tree, and the KNN to do the classification. And the logistic regression has the best performance, but there's no obvious performance gap between the two models. Okay, next part.
Well, that brings us to the end of our presentation. After in-depth data analysis by adopting Python and Tableau, we figure out the correlation coefficient among different variables. For example, Manhattan has the large amount of housing resources and the highest average housing prices, while Staten Island sees the fewest housing resources and the house in Bronx are generally cheaper. Entire home takes up the largest proportion of all the housing resources in New York, and houses with price between $50 to $100 per night are the most frequently seen. According to the numbers of reviews, housing resources in Brooklyn are the most popular compared to other neighborhoods. During the process of model establishing, the influence on the housing prices by several indicators were identified. The most important factor affecting the housing prices is room type, while neighborhood and the available day also have a certain effect to housing prices. We established this price model to provide a reasonable price for new homeowners who have a desire to share their houses in New York. That's the end of our presentation. Thank you for listening.
Okay, thank you very much. Sounds great, interesting. Let's move to the next group, group 4. 赵新建、陈嘉瑞、马金义、王天启。Yeah.
Hi, can you see my screen?
Yes, please.
Okay. Good evening, everyone. And today our group will give the presentation about New York City Airbnb data analysis and prediction. Here are our team members, and Zhao Xinjian is our leader. So before the presentation, I need to give the open source notice first, because we uploaded our code onto the website Kaggle before today, so it was open for several days. After receiving 300 views, and we ranked the first in the hot list. So we turned it into the private version, and after today's break, the code will be open again. So to begin with, here is a brief summary. Airbnb short-term rental platform has made it easier for tourists and hosts to travel So we perform the visualization, modeling, and prediction of the Airbnb listing dataset to study some issues. For example, we study a variable distribution and how to improve price strategy and the naming strategy. Also, here are some relevant issues, and we will answer the questions later one by one. So our presentation is divided into 4 main parts. The first part is about dataset introduction. The dataset describes the Airbnb listing activity and metrics in New York City for 2019. There are 16 variables, and here are 2 simple data from the site. Well, the second part is about data visualization. We study some variable distributions and find out customers' preference for Manhattan and Brooklyn areas. So before data visualization, we need to perform some necessary data cleaning. And the first step is about dropping host name column, because we can use host ID for identification, so it is redundant. And the second step is about setting blank review value to 0. It is easy to understand because if there is no review, the value is 0. Then we study the listing distribution. Through this pie chart, we find that Manhattan and Brooklyn have the most listings, and the least is Staten Island and Bronx, because they have a small population and are far away from the city center. So Airbnb listing mainly serve tourists there. And this is the map. From the original view, we can see Manhattan is the central business district, and the population there is very dense, so it has the most listings. And the orange and blue areas represents the Brooklyn and Queens zones. So because their population ranks first and second in New York City, so they are also popular areas. Well, this is a map from another view, and the point size represents the count of listings. Okay, here is another 3-dimension map, so you can see the conclusion more clearly. And the next one is about room type. For the room type, entire room and private rooms are the mainstream. And interestingly, Manhattan has bigger entire room market than private ones. Customers to Manhattan prefer to choose the larger entire room, and they care less about the price. And we use the listing name to draw the word cloud graph. There are 4 main types of the words. The first one is about a region. For example, there are New York City, Manhattan, and Williamsburg. It is the way that hosts in well-known areas attract customers. And the second one is about room type. It can satisfy customers who have clear requirements about room type. And the third one is about small scenic spots. For example, Central Park, you can see it is in the middle of this graph. And the last type is about descriptive words like cozy, heart, beautiful. It can attract customers who value comfort. Then how about review? From this review distribution by month and year, we can find there is a slowly yearly increase in the review amounts. And we choose the data from 2015 to 2018 for the next analysis because the data before is too small and the data in 2019 cannot cover the whole year, so we just drop them. Generally, we can say there may be 2 peaks among the year. It seems like the summer and the winter. And from this review distribution by month, we can see it clearly. August and December are 2 peaks. Then how about their regional distribution? So here is a graph about review distribution among the year. You can pay attention to the distant areas because they only receive reviews in the summer and winter. The image shows the difference of reviews by region and month from spatial.
I have one comment. So you are gonna to present for your group, like for the whole one?
No, I'm just take one part. Yeah.
Okay.
From spatial view, Ronix and Staten Island only have reviews during the peak seasons, so they may be tourist areas, and natural landscape tourism is more popular in the summer and winter. The last one is about price. From the room types, we can see entire room has more high-priced rooms. It is easy to understand because the apartment is always larger than other types of rooms. And from the neighborhood group, we can see the prices in Manhattan are generally higher. It is also worth noting that the price of shared room in Staten Island is slightly higher than others. It is here. While from the price distribution by month and year, we can see the market has been stably formed since 2015 with a relatively stable pricing strategy. And there is a slightly downward trend in the long run. Also, we choose these 4 years data for the next analysis. Unlike the reviews, the average price varies slightly from month to month. It seems that Airbnb hosts have no obvious seasonal price adjustment strategy. And at last, we perform the correlation analysis to see the relationship between variables. And we found that no variables have strong correlations. Okay, and the next part is about data modeling. I will pass it into my teammate Tianqi.
Okay, thank you. Now let's talk about the data pre-processing part. Okay, first, we can see that there are some abnormalities in the data set. Airbnb is the short run platform, so we had to remove the records with minimized rather than 1 year because they are unrealistic and meaningless. And after that, let's continue to check some values in the data to make a better understanding of the data set. We can see that this page shows the neighborhood and reviews count. We can see that the green one is the Staten Island with the largest number. And this page shows the prices in different regions and for different room types. Combine those 2 pages, we can see that most of the Ivy houses are located in Manhattan, Brooklyn, and they also have the highest prices for all the room types. But the number of customers that hosts can get in these two regions are relatively smaller. And oppositely, Staten Island has the cheapest listing offers by the largest number of customers. This phenomenon is easy to understand. Higher demands leads to more rent offers and also higher prices. And furthermore, let's focus on reviews per month. You can see this page shows the relationship with price. And this page shows with the different room types. We can see some significant differences in different room types. So we can guess that people tend to find a suitable rent price first. Then if they are not satisfied with the room types, they may consider to rent in another region. So the host should use the better pricing, model to make a prediction. And before we get to the model part, we still need to make a standardized to the data distribution. We can see that the price distribution is not standard, and we use a log function to standardize it. And we also use a quantile plot to for checking. And after that, we can prepare the data for training model. There are 4 steps. The first step is one-hot encoding. We use it to transform the categorical features into values that can be processed by the algorithms.
I guess you guys need to control time. It's run over 12 minutes. Okay.
Okay.
Yeah, please quickly wrap up.
Okay.
Okay.
And after that, we standardize features by removing the mean and scaling to unique variance. And we also combine the k-fold cross-validation with grid search to fine-tune the hyperparameters of our model so that we can make a better use of the data set. Okay, I think that's it for my part. Now let's welcome Xinjian to talk more details about the models.
I will just give you guys 1 more minute. Okay.
After proceeding the data, we can train the machine learning model to give some guidance to the future host. We will use 3 metrics to evaluate our model. They are MAER, MSE, and R-square. Next, we briefly describe the model we are using, and we pass the linear regression. Ridge regression addresses some of the problem of OLS by imposing a penalty on the size of confidence. Lasso is a regression analysis method that performs both variable selection and regression. We can see in this image that Lasso uses LE norm
Okay, I guess time's up. So please stop. And
the last slide is a combination of Lasso regression and ridge regression. And the next model is random forest regression, which is made of regression trees, unlike classification trees.
So if you keep on going, I will
MSE
give you 0, okay? I will give your group
instead
0.
of Gini index.
You didn't listen to my voice?
MLP regression uses a 3-layer neural network with a hidden layer of 100 and use ReLU at the
Okay, so I would like to request next group to prepare the presentation. So Jiarui, please ask your group mate to stop because it's running all over time. Okay. And I cannot believe that there's no meaning. I give you guys 0 mark. Okay, you can just stop. No need to keep on presentation. If you guys don't do rehearsal, don't practice, don't manage your time, okay? Please stop sharing and pass the chance to the next group. Okay, let me invite group number 4, Chang Ka-yan, Wen Jiayu, Wang Yibing, and Jin Haoling, please.
Hello, Dr. Zhang, can you hear me?
Yes, please go ahead.
Okay, thank you. Good evening, everyone. I'm Chan Kaiyan. The topic of our group project is Smart Development of Hong Kong in Electricity Consumption. Our project has the above 4 parts. Firstly, I will start with the background of the topic. In recent years, there has been a reduction in fossil products and growing shortage of coal. Coal production capacity is already on the downward trend, and coal supply will continue to come under pressure. This has led to a crisis in the supply of electricity, and the phenomenon of power shortage and ensued. Power outage and restriction have already occurred in mainland China, particularly in the northeast China. For example, Tory Brake Company was affected by the curtailment of electricity production. Mainland China has introduced relevant policy and proposed to improve the double control degree of energy consumption, which is to help achieve the goal of the peak of carbon emissions and carbon neutrality. We can see that electricity consumption in Hong Kong under the impact of COVID-19 has changed. As reflected in the report provided by CLP, electricity in Hong Kong can be divided into 4 main categories, with electricity consumption decline in 3 categories except for residential electricity. Therefore, our team members work together to study the electricity consumption situation in Hong Kong and its objectives. Hong Kong uses a lot of electricity, and we want to explore the issue involved, focusing and analyzing which sectors electricity consumption is more prominent, and we found data for 7 sectors for comparison. In the face of climate change, we should consume less fossil energy. Most of the electricity comes from fossil products, so that means we should consume less electricity, but we also need to develop our economic. Otherwise, our society will go backwards. So we should focus on reducing the consumption of electricity and increasing the efficiency of electricity consumption. This research focused on data analysis with, we were using visualization and linear regression. So next I will pass my group mate to analyze about the next part.
Hello, everyone. My name is Jin Haoling, and it's my time to introduce our data treatment process to you now. And first is our data source. We downloaded our data from the website of Census and Statistics Department of Hong Kong government. And we picked these 4 tables: the population of Hong Kong, GDP, indices of 7 different industry groups, and electricity consumption. First is prepare our data, because there are so many unwanted data in these tables. we use the electricity table as an example, shows that there are so many data we don't want it because like this export to mainland China, we don't want it because we just want to analyze the data Hong Kong people use. So we just compute the data Hong Kong people use and other data as well. And then is the visualization. We plotted the data of total electricity consumption of Hong Kong and total GDP of Hong Kong. And now is what we wanted. This is electricity efficiency of Hong Kong. This is computed by electricity consumed by Hong Kong divided by total GDP of Hong Kong. You can see this is a downward trend, and the variable is the contradictory variable. Why I say that? Because if the variable is small, it means the electricity efficiency is high. So if the variable is lower and lower, it means the efficiency is higher and higher. And we make some comparison to GDP and electricity efficiency. We can say that as the GDP goes up, the efficiency, the variable, the value of the electricity efficiency is lower, and the factor is gets higher. The same as GDP and GDP versus electricity consumption per capita. We can see that in the early stage of our investigating period, the electricity consumption per capita is growing faster than GDP. But in the late stage, the electricity consumption is growing slower and slower. So you said that you tell me why the electricity efficiency is getting higher and higher. Now we do linear regression to find out which sector contributes most to the electricity consumption efficiency. But before we do that, we can see that there are some missing values. We must fix the missing values, or there would be not enough data we can do the linear regression. So we use this as a target, and we believe that the other six sector and the unknown sector, there are some relationship between them. So we do linear regression to predict the unknown values. We fix the model like this. Use the seventh variable as y and the other 6 variable as x, and the formula is like this. And then we fix the missing values. And then we do the linear regression to find out which sector contributes most to the electricity efficiency. We can see the coefficient as this, and we can see the manufacturing sector has the biggest absolute value of coefficient. So we know that manufacturing contributes most to electricity efficiency. And this is, I think this is because the economies of scale, because like the factories, if the factory scale is big, then the electricity efficiency is high. It makes sense. Then we Then we do regression on the growth rate of it. We form the model like this. Then we do regression and find out that the resource saving sector, the seventh sector, resource saving sector has the most contribution to the growth of electricity efficiency. It is
Pay attention to the time.
okay. I'm okay. It's sewerage waste management remediation activity sector. Thank you. It's my teammate.
Hello, Dr. Zhang. My name is Wang Yibing. Let's turn to the third part, our discovery after data analysis. A visual analysis of the data collected reveals that since the 21st century, Hong Kong's GDP, total population, and total electricity consumption have all shown an overall upward trend, but an overall downward trend in electricity consumption per unit of GDP. After the COVID-19, electricity consumption started to trend down again. The social environment and policies involved can be seen to have played a role. There are a number of key points to note in the variation curve of electricity consumption. The first point is the rise in electricity consumption from 2004 because the mainland economic reforms have not only provided a large production hinterland and market for Hong Kong manufacturers, but also created a lot of business opportunities for various service activities. The second point is in 2008. At that point, a downward trend began. The economic crisis has hit both factories and business. The third point is in 2015, the government announced the Hong Kong Urban Energy Efficiency Blueprint, setting a target of reducing energy. The fourth point is 2020. There is overall decrease in electricity consumption due to the COVID-19, which has affected people's daily lives and business activities. We believe that based on the result of the data analysis, it can be seen that total electricity consumption and per capita electricity consumption in Hong Kong will be on a downward trend in the future. The first reason is that the epidemic is likely to persist in the coming years and continue to affect people's daily lives, work patterns, and business activities to some extent. The second reason is that Hong Kong's energy conservation policy.
1 more minute.
Technology has been focusing on energy saving and emission reduction. Let's turn to the summary.
Hello, everyone. My name is Wen Jiayue. In order to better follow Hong Kong's goal of achieving carbon neutrality before 2050, this trend should be maintained or continue to develop in a more efficient manner. The energy consumption of built environment is the largest source of carbon emission in Hong Kong, and electricity generation accounts for 67%. To achieve carbon reduction, there must be more clean and zero carbon energy. Zero carbon energy means that in the process of energy production and use, the energy does not increase carbon emissions, just like solar energy, wind, tidal, hydrogen, biogas, etc., especially focus on the sector 7. And because of the technology and neutral resources, Hong Kong does not have favorable condition for large-scale reduction of communal renewable energy. So it is necessary to use regional cooperation, overseas enlargement, joint development, and—
Time's up. So you guys use all 13 minutes. So let's move to the next group, group 6. Ri Ka Yan, Yu Yun Lin, Cao Ta Xin. Yeah. Thank you, group 5.
Thank you.
Let's move to group 6.
Yes.
Yeah, please share your screen and start
Yes.
your presentation.
Hello, everyone. Can you hear and see the screen?
Yes, I can see your screen. Please.
Thank you so much. So we will start our presentation soon. Yes, we are ready.
Yes, good evening, everyone. Today we would like to talk about the global smart city indicator and index analysis and exploration. Next, this is our content. And next, first, let me to introduce a smart city. A smart city is defined as the use digital technology and data to solve any problem and improve life. As a result, many local authorities have consistently introduced a different technology and development system is recent decades, but they have failed to address some of city's most important issues. Indirectly, in many cities, we see a emphasis on developing products that reduce the quality of life. Therefore, objective of our finding is to be global smart city, full comparison with different performance, and find out the suitable equivalent to analysis distribution of indicator for best smart city. Next, and the processing data and development equivalent is separate free part. And after that, we will have a sum up section. And next, let's see the data information of data set. Their ranking text is 102 and total trials data column, including the set indicator. And next, their data is show the city and country list. And also our data is counting with set. And next, and also our data in counting with safety indicator and index for mean, STD, minimum, and maximum.
So here is the data overview, and totally 102 data from the different city and six smart smart city elements were evaluated to come out smart city index. The highest score of the smart city index is around 70,300 marks, and the lowest score is around 4,000 marks. And here we have explored and processed the data set for building the different algorithms and AI models. 80% of the data was split for the training model, and the balance 21 sets of data were used for model testing. Of course, in order to let the model more fit with the training data pattern for optimizing the model prediction accuracy, the cross validation was performed, and 10-fold cross validation was carried out in our different model prediction. So this is showing the raw data pattern for Waverly screening. The cross relationship between each element and index can be shown by this graph. It provides us to have the brief concept and advanced understanding of data before applying different algorithms. Okay, so in this project, we utilize some other algorithms to conduct the experiments. The first one is decision tree. We have used to classify called the best fit tree. It finds out the strongest relationship between the smart city level, which is the smart city index. This is because the level is calculated by the index to distinguish above and below average level. We can see that the accuracy is high, around 99%, and which means square error is low, only 0.08. However, this result cannot provide us any findings regarding the smart city elements. Therefore, we have utilized another classifier to perform the decision tree action, which is called alternative decision tree. In here, you can see that the smart city index is taken out from attributes for the experiment. Now we can examine the relationship between the smart city level and the 6 smart city elements. Here is the alternative decision result. Smart living is the critical element to influence the smart city level. Then is the smart economy and the smart government, etc. Regarding the performance of this algorithm, the accuracy is rated as around 91.1%, and the RMSE is around 0.27. Although the performance is a little bit lower than that of the best fit tree, This alternative decision provides extensive information and analysis results for our reference. So please have a look for the next page. And here is the tree system, which is the result running by the algorithm. The importance of each smart city element is shown here. As mentioned previously, the smart living is one of the critical elements to provide a smart city level. Negative value means smart city level is tends to be above average. For example, the smart living and the economy elements value are minus 0.7 and the negative 0.8. The score of these two critical elements should be get over around 5,000 and 7.7K points respectively in order to achieve the above average level of smart city. By this decision map, we can have a better understanding about the elements relationship. After the decision tree algorithm, here we would like to share our findings in different regression experiments. The first one is KNN algorithm. It is worked by finding the distance between a core and all the data in a dataset. Here is the accuracy of our KNN experiment, which is around 95%. And here so is the CV score, as mentioned at the beginning of the presentation. 10 cross validation is carried out for teaching the models. Besides, CV score can be used to compute the mean square error. In our case, the minimum MSE is 0.06, and it should apply only 1 year's labor for classification to have the best prediction performance. That means the lowest RMSE is and the highest accuracy of the algorithm. Next, more regression of the experiment and results are going to share by my teammates.
Thanks, Ken. Let me talk about the linear regression. That is the process to find a line best fit in the data point available, that we can use it to predict the output value in the dataset. Next, in our data result, we would like to know more about the data about modification, government, economy, people, and living. From the data result, would mean square error, RMSE was 0.3. RMSE result between 0.2 and 0.5 show that the model can be predicted to the data accurately. Truth, it showed that the linear regression result is accurate. Next, for the SVM, that is the set to learning method to use for classification, regression, and auto detection. We would like to know more about relationship between smart people when compared with other areas. You can see the result is different. For example, when compared with smart people and smart mobility, below average data is in red color. It shows next page, please. For the below average data is in red color. It shows that the range is smaller when compared with smart people and smart economy. That may mean the country may more focus on the smart economy area. Next, for the logistic regression, it uses a software to understand the relationship between departed reliable and one or more independent variable to analyze probability when using logistic regression equation. Next, finally, which algorithm result is more suitable to analyze in our case? Next, in the result, RMSE is smaller when it is using KNN. That means more accurately when compared with others. Choose. We would like to use KNN method to analyze in our case. Like you can see, that's why we can choose KNN. Next, you can see the smart city score depends into below average and above average. The data when compared in the different smart city section. For example, Singapore is the highest score in the smart people and smart living, And at the same time, we can find same result in the internet that is the same. Truth, it may prove that our result is correct. Next.
Finally, we would like to adjust the distribution of set indicator to become smart city, such as mobility index data to assess the health of city, environmental connect computer to other daily activity and service. Government use technology to facilitate to support better planning and distribution market. And economy, all action arms the transportation and shrink funding electrical economy. People transforming the way cinema and interact and smart form of education and living improve the quality of life and tools through the comprehension approach. And our arm is building a smart city to be a safe city. Next. This is the end of our presentation. Thank you.
Okay, thank you very much for
Thank you very much.
yeah, group 6, nice time control and also a good work. So
really
okay, so we will take a break, 10 minutes break. We will come back at 8:35. Okay, then the next group 7, 邓格格、傅毅、钟玉玲、莫嘉欣. Yeah, please prepare. So you guys will start your presentation at 8:35. Hello? Okay, let's invite group 7. 邓格格、傅毅、钟玉玲、莫嘉欣. Yeah, please.
Hi, Professor. Can you see my screen share?
Yeah, I can
Okay.
see.
Fu Yi, you can start now.
Okay. Can you hear my voice? Wait,
Yeah,
can you hear my voice,
yes,
Professor?
yes,
Oh, okay, thank you. Now, hello everyone. Our topic is analysis of demand for share bikes in London. Next. The first chapter is research background. There are our contents. There are 5 parts of our presentation. Next. As an innovative form of urban public transportation, share bikes have effectively alleviated people's travel difficulties. However, when cities gradually promote the construction of share bikes, they are also accompanied by a series of problems. Therefore, it is of great practical significance to predict the demand of urban share bikes for the entire share bike system. The purpose of this paper is to predict and analyze the real-time demand for share bikes in London. Next. The second part is literature review. L. Freeman believed that the random forest was essentially a classifier. One of the advantages of RF is that it can be used for both classification problems and regression problems. Li Jingyang believes that RF can evaluate the importance of variables in the training set during training set classification. A. Prinzit believes that the core of RF is randomness. Next, thank you. Random sampling of sample datasets and random selection of tree construction features are used to reduce the correlation between decision trees, further improve the accuracy of the model, and enable RF to have advantages such as fast training speeds, easy parallelism, and good classification performance. Next. Okay, next. Now, welcome my teammate to introduce the next chapter for you. Thank you.
Next part, we will analyze the demand characteristics of shared bike. Our data set is the historical data for bike sharing in London, including the date, time, weather situation, and the count of the new bike shares. Consequently, we will evaluate on time and weather factor and find out the factor that has a significant impact on the usage, which will put it into random forest model. So first, as for the season factor, according to the data analysis in Excel, we found that season has a significant effect on the usage of shared bike, while the bike usage is higher in summer. Next. As for the month, the effect of the month is not significant since the difference of months in the same season is not obvious. Next. Whether it's weekday or weekend has a significant effect, while during the weekdays, the usage of the shared bike is higher. Next. The effect of days in the week is not significant as whether is weekday or weekend, which would not be considered. Next. Hours in one day has a significant effects since it can be clearly seen from the figure that the curve of the user's riding volume changes with time is in the form of double hump, that is the morning peak and the evening peak. Next. Weather is holiday has a significant effect, while during the non-holiday days, the use of shared bicycle is higher. Next. As for the weather factor, the real temperature has a significant effect, while there is a certain positive correlation between real temperature and riding volume. Next. Similar to the real temperature, body temperature also has a significant effect on usage of shared bike, while it also has a certain positive correlation. Next. As for the humidity, there is a certain negative correlation between humidity and riding volume, so it also has a significant effect. Next. As for the wind speed, the peak usage of shared bike is around 24.5 kilometers per hour. So it also has a significant effect. Next. Weather has a significant effect while the weather is clear, scattered clouds or broken clouds, the usage of shared bike is higher. Next.
Now, although we know the interrelationships between the demand and these other factors, but we do not know the specific significance of each factor. So we will do the experimental verification and analysis and try to figure out what is the most important factors. So after the data cleaning, we divide the data set into two sets respectively for training and testing. And we import the pandas and the random forest regressors in the Python environment. And we define Y as the count, which is equivalent to the demand of the share by usage in London. And we define X as other factors. And then we do the training. And we can figure out that the importance of each factors, and we can find that time is the most important factors. Then we use the test sets to do the testing. Then here comes the output of the results. And we can find that the estimated demand curve and the actual demand curve in non-weekend data has a better fitting and can be track the demand of the share buys in each time of period. And in summary, we can find that the random forest performs better when applied on the prediction of non-weekend share buys demand. And second, the most important factor is the time. And also 9 a.m. and 6 p.m. are the peaks of share buys usage during the workday.
Okay, now it's my turn to draw conclusions and share the limitation. Next, please. After the correlation analysis, we find that the demand for shared bicycles is related to the time, which is including the season, the hour, the holiday, and the temperature, humidity, wind speed, and the weather. However, the above correlation analysis does not conclude the degree of the importance of the factors. So we use the random forest to change the existing data and focus the demand of share bike. And the biggest, and we find that the biggest influential factors in the demand for share bike is time. And in terms of forecasting, the best predictions were made on weekdays after goodness of face tax. Next, please. So what can share bicycle company can do? And firstly, the company should focus on the specific point in time. And before the time, the company should complete the deployment and then increase the station available in detail. That is the weekdays and non-holiday, because that time we find that it has the largest demand for the bicycles. And at the morning and at the evening peaks, that is 9 a.m. to and 6 p.m. the people has the largest demand for the share bike. Also, the company should keep an eye on temperature, humidity, wind speed, and weather condition. Specifically, that is the temperature over 20 degrees, the humidity around 25.5 to 28.5%, and the wind speed peaked at 24.5 kilometers per hour. And the weather is the cloudy, because these conditions are also the most influential factors for the bicycle demand. Next. Now let's come to the limitation. In this project, machine learning was used to analyze times as an important factor, so we only predict this factor. And however, no further predictions could be made for a wide range of factors such as the weather and temperature. So the conclusion of this study are not precise enough. And due to the limited data resources in the database, we are unable to figure out the demand for shared bicycles at specific station and cannot further decide the deployment plan. That is all our presentation. Thank you for your listening.
Okay, thank you very much. So it's a quick one. Let's move to the next group. It's a nice data analysis. So let's move to group 8. Let's invite Li Xin, Gong Xinxin, Yang Zhongji, Pan Jiayue. Please share your screen and start your presentation.
Hi, Professor. Can you see my screen?
Yes.
Good evening, everyone. It's my honor to be here to make this presentation. Our project mainly consists of the air quality of Guangdong province. So our topic is the temporal spatial features of PM 2.5 and AQI in Guangdong province and the influencing factors analysis. In this topic, the AQI means the air quality index, and our team members are Yang Zhongji, Pan Jiahua, Li Xin, and Gong Xinxin. There are 5 parts of our presentation, including the introduction, data processing, research methods, results analysis, and conclusion. The part 1 is the introduction. As we know, Guangdong province is one of the most developed economic regions in China, with a high level of urbanization. However, with the rapid economic development, we should also improve the environment simultaneously. Conducting this research can not only open up new ideas in the field of environmental health research, but also provide a strong scientific basis for controlling air pollution. The research area is Guangdong province, including 21 cities, and the research period is from January 2050 to December 2020. And our research dimensions mainly include the following 3 aspects: the temporal, spatial, and impact factors. And our research contents are PM 2.5 and AQI. In a word, we mainly based on the air quality data and climate data to explore the temporal and spatial characteristics of PM 2.5 and AQI in Guangdong province. And we also explore the influence of climate factors and social factors on air quality. The second part is the data processing. The data of our topic mainly come from the Open Guangdong website and Guangdong Statistical Information website. The data set mainly include the data of AQI, the data of climate, and social factors. And the data processing tools are Python, Excel, and Tableau. The data processing, since the PM 2.5 average daily and monthly concentrations are available in the data, so we use Python to extract the seasonal and annual average concentration values of PM 2.5. Okay, that's all about the first 2 parts. Let my teammates introduce this part.
And I'll introduce the research method parts and a part of result analysis. The first method we use is called global spatial autocorrelation. We calculate the Moran sign, and you can see the formula on the right. It was used to determine the geographic spatial aggregation or dispersion features of air quality. It can help us to identify whether the distribution of attribute values of spatial objects has a positive correlation or negative correlation, or there's no spatial correlation. And next, the local spatial autocorrelation is to analyze the aggregation and distribution of AQI in local areas. That is the correlation degree of air quality between a city and its neighbor. It can help us to identify different clusters on the map. And for doing analysis on influencing factors, we use linear regression. It's a widely used regression analysis. It can help us to determine the quantitative relationship between two or more independent variables. And now I'll jump into the result analysis part. We divide it into three parts, and let's first focus on the time variation features. So from a year-to-year perspective, the PM2.5 concentrations of main cities in Guangdong show a decrease in trend, and from 2015 to 2020, with most cities only showing a relative high point in 2017 and gradually decreasing thereafter. This indicates a steady improvement in air quality in Guangdong. Then we look at it from a quarterly perspective. The PM2.5 concentrations in Guangdong province has typical quarterly features, and we can see an obvious U shape of the PM2.5 curve. The PM2.5 concentration in first and fourth quarter are relatively higher, and we can see a much lower in second and third quarter. This is due to heavy summer rainfall in Guangdong province, and it brings some clean air. Moreover, we did some analysis in terms of every month. We can observe that the PM2.5 concentration in Guangdong not only has a quarterly features, but also have strong monthly variation features. The curve shows a V shape, and the PM2.5 concentrations decreases from January to the lowest value in June, and then it increases every month. So we can actually draw a similar conclusion as the quarterly analysis, that the air quality is good in summer and poor in winter. And next, my teammate's gonna talk about the rest part.
Okay, let me introduce you the space variation features. This graph shows the spatial distribution of PM.5 annual average concentration in Guangdong province. We can observe an overall trend from slight increase to substantial decrease. In 2018, nearly the half of the cities in Guangdong province still exceeded 35 micrograms. This limit is based on environmental air quality standard. The situation improved in the following 2 years. In 2020, the annual average PM.5 in the whole province was less than 35 micrograms. Besides, this graph shows a typical feature of higher in the northwest and lower in southeast. In the northwest, cities such as Zhaoqing and Qingyuan have higher concentrations, while in the southeast, cities such as Shenzhen, Huizhou, and Shanwei have lower concentrations. Now I'm going to move on to spatial autocorrelation methods. This table shows the global Morris eye of annual average AQI from 2015 to 2020, indicating that AQI of 21 cities in Guangdong province is in a spatial positive correlation. Then we draw some plots and try to figure out the local spatial autocorrelation. For example, in 2017, the scatter plot shows that AQI presents an obvious trend of local spatial autocorrelation. The graph in the middle shows that Qingyuan, Foshan, Zhaoqing, and Zhongshan were in the high level area, while Meizhou were in the low value area. From the perspective of the whole province, the high value areas are mainly concentrated in the northwest and the central cities, which is consistent with the overall features of more serious pollution in the northwest. Okay, my team members will introduce you the rest part.
Hello everyone. So now let me introduce the third part of the result analysis. That's the influencing factors of PM 2.5. The procedure can be divided into 3 parts. The first step is to select the main influencing factors of PM 2.5 concentration. And the second is to construct a multiple linear regression model to quantify the impact. The third is to explore the relationship between the structure and between the impact and the third is to quantify the impact and explore the relationship between urban economic structure and the air quality. So the main influencing factors can be divided into 3 categories. The first is climate factors, and the second is social factors. But the third one is lag factors, since air quality is affected by influencing factors not only in the same period, but also in the past. So after standardizing the factors to the same scale and filtering factors by doing multicollinearity test and non-hypothesis test, remain the factors of which the coefficients are significantly not known. We added different combinations of factors into the model to see how the factors improve the fitting. First is the only the climate factors, and the second we add the lag factors, and the third the social factors. As we can see, the model is improved significantly, which indicates that the historical data of PM 2.5 as well as the social factors is very important to the model fitting. So, this formula is the final multilinear regression models, and the table shows the result of our regression. And as we can see, the R squared is pretty well, and the MSE is much lower. So as the results shown in the table, all the climate factors are negatively correlated with PM 2.5.
1 more minute.
And there are only 5 of the 13 social factors are significantly correlated, and the lag term has a positive correlation, which shows that the historical PM 2.5 concentration has a significant impact on the current concentration. Therefore, it's necessary to formulate a long-term plan for the air pollution control. Besides, we find that there is a significant negative correlation between the secondary industry and the PM 2.5, which is counterintuitive. We think it might be related to the implementation of sustainable development measures. So the figures shows the model fitting result, and as we can see, the model is able to fit
time's up.
very
You
well.
have to stop here. Sorry, it has been
And
like
the fifth part is our conclusion. According to our
it has
analysis,
been 13
there are
minutes,
3
so you have to
conclusions.
stop.
First, from the perspective of time dimension, the annual mean value of PM.
Okay, so let me invite next group, 子依然、马池、田玉芬 and 何同浩. Yeah, please. Yeah. Group 8, please stop sharing and stop your presentation. I'm sorry, group 8, you have already used up 13 minutes. Okay.
Okay.
Yeah,
good evening, everyone. The title of our project is Analysis of having data and advice about public policy based on machine learning methods. Next. We are going to talk about the 7 parts. The first section is introduction. Airbnb is the most popular platform in the homestay industry. Its data contains information of the tourist and housing market of Hong Kong. 2 events have a major impact on Hong Kong, the Mars protest and COVID-19. For our data analysis, we use data from Airbnb website in 2019 and 2021. Next. We have 5 research proposals, which will be explained in detail later. Next. The second part is data processing. We perform data processing, deal with non-values and outliers, and divided the data into 2 groups, one with review sources and one without. Next. The third part is data visualization. Compared with the data in 2021, the number of the Airbnb homestay hotel is higher and more widely distributed in 2019. But because the homestay industry is in serious decline due to the COVID-19, and many Airbnb hotels have closed. Next. From the pie chart, we can see that the proportion of Airbnb homestay hotels to the hotel number is similarly in each region in 2019 and 2021. Next. As the bar charts show, we can get the number of Airbnb homestay hotels with different room type also have a significant decrease in Hong Kong. One of the most obvious is a drop in the number of inter-home and/or apartment type Airbnb homestay hotel from 3,000 in 2019 to less than 2,500 in 2021. Next. In 2019, Airbnb homestay hotel prices are concentrated in 0 to 1,000, but in 2021, prices are generally below 500, which we can guess is caused by the decrease in travel, study abroad, and other activities due to the COVID-19. Next. In 2021, the average vacancy rate for Airbnb homestay hotel of our room type increased in all regions compared to 2019, indicating that many hotels are really booked now. Next. I finished.
Okay. In the first part, I do a clustering analysis, in house or all house data. And let me introduce the basic principle of k-means. For a given sample set, D, we can divide it into k clusters. In the process, algorithm minimize the SSE for all the clusters. And the smaller E is, the closer within a cluster, and the higher the similarity between sample is. Next. And we can divide it into 5 steps. The first is select a k value. The second is create k clusters. The third is calculate the distance and do classify. The fourth is calculate and update. We can repeat the steps before until the result doesn't change again. Next. We mentioned that the cleaned data set was divided into 2 sets, and we do k-means part by part. When we select a k, we choose the silhouette coefficient methods. The silhouette coefficient methods quantifies how small the gap within a cluster and how large the gaps between clusters. From the left part, we can see that the highest silhouette coefficient appeared when k equals to 2. So we choose k equals to 2 after. Next. Next, please. Okay. Then we draw the last page. Then we draw scatter plots in 2D plane. We can see from the left part that the boundary between the different colors are clear and the clustering effect is good. Then we can see the right part. They are the clustering results. The price, availability, and the scores are picked out. And next. Finally, we merge the result of 2 data sets into 1 table. Then we use our experience and network resources to divide 4 clusters into 3 classifications, which are A00. It's a high price unpopular type. Such houses are usually booked less because the price is high and they are unsatisfactory. The B type is high priced popular type with high score or no score. Such houses are welcomed by the consuming population in high hierarchy. And the C11 is a low price unpopular type. Such houses usually have poor supporting facilities and others. We can see that the B type is more than 1/3 of all data. Next. The lower price type and the high price has its own reason and conforms to the traditional cognition, but the high priced hot type, that is the B type, accounts for 37.05% of all data, exceeding one third at the time point in September 2021. Under the background of the pandemic, such a large-scale high-priced hot houses worth exploring in depth, and we will do some analysis and exploring in the next part. Okay, finished.
So next is part 5, predicting the price. Next, we want to explore whether we can predict the house's prices and figure out some insights about prices. For example, which variables are important in predicting prices, and for the categorical variables, will there be any trends in prices between different categories? So we use the linear regression model to predict the prices of the houses. We constructed the model using 2019 and 2021 dataset respectively. We choose the following predictors: accommodates, number of reviews, review scores, neighborhoods, and the room type. Next, this figure shows the coefficients of the model for 2019. Significant testings show that accommodates and number of reviews are significant. Review score is not significant. For the neighborhood, Southern, Central, and Western, Saikang and Wanchai have high coefficients and are significant. For the room type, entire home and apartment is significant. Next, for 2021, dataset is a little bit different. Accommodates is also significant, but the number of reviews is not significant. Review score is significant. The results of the neighborhood and room type is pretty similar to 2019 dataset. And for the evaluation for 2019 test set, R square is 0.42, and for 2021 test set, R square is 0.3. It seems that especially for 2021, the model is not powerful enough. Next. But the results seem to be reasonable. Accommodates is the most important predictor in both 2019 and 2021 model. As our common sense, the price of the larger accommodates houses tends to be higher. One interesting thing is that the coefficient of the number of reviews is negative and significant in 2019, which means that cheaper houses tends to be more popular. But in 2021, it's not number of reviews, but the review scores is significant. Moreover, the coefficient of review scores is not negative, but positive. This indicates that during the epidemic, houses with high price are more popular. This is the same as the results in part 4, and we will discuss why in the last conclusion part. Next, the neighborhood results can be formed with the real average price data from this table. Southern, Central and Western, Sai Kung and Wanchai, this central location in Hong Kong Island appear to have high average housing price. And for the room type, as we can see in real life, entire homes and apartments are more complete and have more furniture or other living facilities. Consequently, the price tends to be expensive. Next.
And so the sixth part of our work is about the occupancy rate. This rate represents the state of utilization. We try to predict the occupancy rate using features like location and type of room and see how they influence the rate. And the response we choose is availability 365, which is available days of the listing in the future 1 year. And then we choose 6 predictors. The correlation matrix shows no clear linear relationship, so linear regression may not be suitable. We'll try other methods. We use linear regression, Heian and gradient boost, and random forest methods, and apply the K-fold method to do model selection. The result of the model is shown on the slide, and we can see that the gradient boost model performed best. But when we fit the model, we see that the R-square is only 0.2. We think one possible reason for poor performance is that availability 365 is not an ideal response. It has some confounding factor. A room can be not available because it has been booked by a guest or blocked by the host, so we cannot distinguish between the two reasons. And secondly, we may omit other important factors that are not shown in the dataset. So we then instead use the exploratory data analysis method. This figure shows the occupancy rate in Hong Kong's 18 districts, and the lower the position of the box, the higher the occupancy rate. Note that Central Western already own a large number of listings, yet the occupancy rate is almost the highest, indicating that this region is popular for visitors. For room
Sorry, your time probably is running up. So if you can wrap it, please do that quickly.
Okay, so let's jump to the conclusion part. First, we explore the phenomena in part 4 and part 5, and we think that the reason for high price are more popular during the epidemic is that local consumers become mainstream during the pandemic and they cannot go away for a long trip. So they instead go to high-level hotels for short vacation. That is a staycation. And also, based on the findings of part 6, we advise on how to improve the tourism and homestay market after the pandemic. The demand is highly centralized in Central and Western district. So on one hand, the tourist season, there may be shortage of rooms in this district. And on the other hand,
I'm sorry, due to the time limit, so you have to stop here.
Okay, sorry.
To save the time for other groups. Sorry about that, but I saw your second conclusion, so that's fine.
Okay.
All right, so that's invite group 10, 龚叶英帆、王一彤、张林杰 and Sun Jingyue. Yeah, please prepare.
Good evening, everyone. I'm Sun Jingyue. Today, we will talk about research on traffic accident analysis based on smart transportation. Take France as an example. Next. Our presentation is divided into 4 parts. Next. And I will introduce the background for you. Next. Urban ability is one of the basic human needs for food, clothing, shelter, and transportation. And with a growing population, an increasing number of cars, and a continuously aging, physically constrained transportation infrastructure, putting enormous pressure on urban transportation. How do we weigh the pros and cons of congestion, travel convenience, and pollution? Smart transportation that uses smart city IoT technologies to improve the quality of mobile travel, save energy, and reduce pollution is now the future transportation orientation of every country. Traffic accident refers to the event that the car causes personal injury or property loss due to fault or accident on the road. Traffic accident historical data is important basic data for road traffic safety related research. The reasonable and efficient application of data is an effective way to fully reflect the value of accident data. Next. Smart transportation refers to the integration of the IoT, cloud computing, big data, AI, and other new technologies on the basis of traditional transportation to gather a full range of traffic information so that the transportation system in the city and other areas with the ability to sense interconnector analysis, prediction, and control to achieve the combination of people, cars, roads, and the environment. Next. In order to effectively prevent and control road traffic accidents and reduce accident hazards. Many scholars have devoted themselves to studying the regular patterns of traffic accidents and building traffic accident prevention mechanism. In this research, we will start with France and analyze the influencing factors of traffic accidents and propose some improvement measures and suggestions for the current urban mobility and smart transportation. Next, let's welcome our team member Zhang Lingjie.
Okay, I will talk about the research methods. First, we did some basic data statistics with the data set accident in France from 2005 to 2016 from Cargo. We mainly focus on three, next please, next page. We mainly focus on three significant features: the time, the lighting condition, and the type of intersections where the accident happened. And we got these plots. It did reflect something, at least the proportion of features in this data set. But since we don't have the traffic volume data and the number of intersections in France and the weather data of these 12 years, we can't take the non-accident happened data into consideration. So I think this plot seemingly meaningless. Next. So we considered another way to analyze the data, the k-means clustering. We didn't use the k-means because we had a categorical data set, which means it is hard for us to define a distance to calculate the means. But k-mode can help us because it can use the dissimilarities between the data points. We first calculate how many clusters should be the best to deal with the data. After twice round code, I think 13 is the special point because before 13, the slope is steep, and after it becomes gentle. Then we calculate the frequency to make it more meaningful. We calculate the risk, which is serious accidents divided by the total accidents in each cluster. A serious accident means that there was at least one victim. Next page, please. We picked the three highest risk clusters and compared their features with other clusters. And after discussion, we labeled them accidents that happen at the crossroad with traffic lights, since the rate of the collision by the side is much higher. And accident happened when two cars meeting, because the collisions are many on the front. And the last one, accident happened when motor vehicles collision with non-motor vehicles and pedestrians. And finally, next page, please. And finally, we made some research on these three clusters, and the detail will be given by my roommates. Thank you.
Okay, let me introduce our research results. Firstly, according to the chart of data analysis, the number of accidents is not high in poor lighting conditions and is much higher in night with public lights on compared to night lighting not lit. This may be due to the fact that the drivers are more alert in poor lighting conditions. And through analyze lighting conditions and the number of accidents, the number of accidents are higher during evening rush hour and much lower in morning rush hour compared to the evening rush hour. And this may be due to the fact that speeds are better in the morning than in the evening, and that the speed of traffic going home is usually faster than the speed of traffic going to work. And according to the number of accidents based on the intersection type, during the research period, the number of traffic accidents out of intersection is nearly 600,000, which is much higher than that at intersections. It's possible that due to the good field of friction at the intersection and traffic light control, the driver will be more vigilant with vehicles meet. And moreover, accident rate of X and T intersections are the highest and the second highest respectively. And the accident rate of Y and more than 4 branches intersection is lower. Even if vehicles meet, the probability of collisions is small. Moreover, the situation of intersection with more than 3 branches is more complex. Drivers will be more vigilant and pedestrians will be very cautious when crossing the crosswalk. And for the rate rate, accident rate is between the high X and T intersections and the low multi-branches intersections. It may be that the intersection has poor vision and cannot directly observe the road condition. There are vehicles merging at any time, so there is a certain risk of accident. However, the circular route is single and the traffic rules are well formulated, so some accident possibility are avoided. And after we use the model, after 2 clustering operations, we found certain as a special intersections point and select the number of cluster tabs. And for cluster 10, we compared it with other mean values and get 11 component diagrams for analyze. And for variable lectures, for the high-risk cluster, there is no light at night. The accident mortality is very high. On the contrary, the rate of major accident during the day is relatively low. This means that driving light conditions are still important. And under the influence of agglomeration degree in cluster 10, traffic accident risks of areas is less than out of agglomeration. And for atmospheric conditions, cluster 10 is very close to other types of traffic accident risks under the same condition. And in different periods, the traffic accident risk of cluster 10 at dawn and night is higher than of others. Now welcome our teammate to give some suggestions.
According to the above research, under the time, light intersection and other influencing factors is reflects the following causes of the accident. The road control system is not perfect. The drivers have a weak awareness of abiding by the traffic regulations and the insufficient combination of science and technology with the road. So the following suggestions can be made. Firstly, increase the proportion of overpasses or low accident rate roads in terms of traffic road improvement. Secondly, in terms of the smart traffic accident management system, the application of information internet and other technical means through navigation software, road guidance medium, reasonable planning route, help traffic diversion. Through the development and adjustment of cluster modes to minimize the number of exchange packets between sensors in order to save battery life, in order to minimize the number of exchange packets. The optimal route from the accident site to the nearest rescue site was calculated and determined by developing a dynamic routing scheme calculated from the control station based on the cost heuristic function, use warning message patterns, and draw obstacles on some routing passes to predict the cost and minimize the likelihood of an accident. Finally, strengthen traffic supervision and strengthen education and publishment for drivers. Okay, that's all. Thanks.
Okay, thank you very much for group 10. So that's a nice analytics. Let's move to group 11. I would like to invite Dong Liang Liang Kai and Zhou Shucheng and Song Fenyi. Yeah.
Hey, can everybody see my screen?
Yes.
Okay. Hey guys, this is Dong Liang speaking, and we have Liang Kai, Song Fenyi, Zhou Shucheng here as well. So first, Liang Kai is gonna talk about the project context.
Hi everyone. Now let me introduce our project content. Our dataset is from Kaggle and it was originally published by the New York State Testing Commission. The training set and the testing set totally contain over 2 million vehicles with 11 attributes in each of them. Next, please. Next, maybe, yeah. Here are the details of the dataset. The ID is the Unicode identifier, and the trip duration is the target to be predicted. The predictors are the time attributes and the geographical attributes, including the pickup daytime, the drop daytime, and the latitude and the longitude information. Next, please. As shown below, here is our objective of our project. Firstly, we use K-means clustering algorithm to analyze the intraday traffic flow of New York City. Then we conducted exploratory data analysis on relationship between traffic and days, location, number of passengers, and so on. Finally, we compared the performance of different models and choosing the best one for application. And now please welcome my teammate Dong Liang to explain more about the result of our study.
Hey guys, so now I'm going to talk about the first part of our analysis, which is intraday traffic flow of New York City. So after loading the training data and the required packages in Python, so our first step is to plot the rides based on the longitude and latitude of pickup and drop-off points. So here you can see the x-axis is longitude and the y-axis is latitude. And our second step is to use K-means clustering algorithm to partition the taxi rides into different clusters. And we can notice here that the clusters that we get from the K-means clustering algorithm partitions the New York City into the different districts in real life. So on the left of this slide, this is a picture of the New York City. So we can see a one-to-one mapping here. So here is the Upper West Side here. And we also have like financial district over here. And on the far east, we have JFK Airport. And notice that the middle part is empty because it is Central Park and you cannot possibly drive any cars through the Central Park. All right, so let's get to the next slide. So then we plot the center of each cluster we use arrow to represent traffic flow from one cluster to another. And the width of the arrow is proportional to a traffic volume. So like that means like the more traffic volume, the wider the arrow is. So I'm gonna show you guys here. So this is more clear. So right. So first we can see that in the morning, most traffic are within Manhattan, like right here. This is because people commute to work. So starting from 6 a.m., we can see that traffic in Manhattan Island begins to increase, and it lasts all day till 4 a.m. in the evening. And the second part that we notice here is we do not see many number of taxi rides to JFK Airport between 12 a.m. Between 12 a.m. and 5 a.m. So here, we don't see any rise here. So this is because the last flight is around 12 a.m. and the first flight is around 5 a.m. And another thing that we noticed is that the number of taxi rides from Manhattan, which is here, the Manhattan Island to Brooklyn, begins to increase from 6 p.m. And it almost diminishes around 3 a.m. However, we do not see many taxi rides from Brooklyn to Manhattan in the daytime. So my guess here is, so these are the people living in Brooklyn, but they work in Manhattan Island. So, and the last subway from Manhattan to Brooklyn is scheduled around 11 p.m. So they, so after they finish their light shift of work, they have to take a taxi ride. All right, so let's get right back to the slide. So the next part is exploratory data analysis. So first, we can see that the taxi rides. So this figure is about taxi rides duration across hours of one day, and we can see like these 7 lines represent from Monday to Sunday. And the first thing we can see the taxi rides duration increases around 6 a.m. and it reaches peak around 3 p.m. And the taxi ride duration implies the real-time traffic status. And we also can see the taxi ride duration in the evening is around 15 minutes, which is much shorter than that in the daytime. And this is, and normally we would expect taxi ride duration to be shorter during the weekend, but it is not the case here. We can see that the traffic duration in Sunday is almost equivalent to Monday. So the next part is going to, Songfeng Yi is going to talk about this part.
So these two figures is about the mean of trip duration in a day, and it's the first one is the pickup one, and the second one is about the drop off. So according to the figure, the peak of the first plot is around 10 p.m., which implies that there are more people arriving at the airport and waiting for the pickup. And the peak of the second plot is around 4 p.m., which implies that there are more people going to the airport. As we see, the airport is the JFK airport, which is in our Manhattan. Right, next one, please.
Right. So the y-axis for all these 4 plots is the number of rides. So first, for the first plot, we can see that most people they get a taxi ride by themselves. And the second plot, we can see that the distribution of the 7 days of the week. We can see that like Saturday, Friday, and Thursday, they have the most taxi rides. In the third plot, we can see the taxi rides distribution of the first 6 months of 2016, and we can see that March, April, they have the most rides, and the last plot here is the taxi rides distribution by the hours. We can see that most people, they take a taxi ride around 6 and 7 p.m. And now we have the interaction heat map between all the clusters of New York City. So this heat map shows the number of taxi rides from one cluster to another. So for example, like this rectangle here, it shows the number of taxi rides from the x-axis, which is JFK, to the y-axis, which is Harlem, right? And we can see that the darker the color, the more rides from the cluster to the other cluster. And we can see Midtown, downtown, and Upper West Side, Upper East Side. These districts have the most taxi rides, and the number of taxi rides could be positively correlated with the average income of that district, because we don't see too many taxi rides in Harlem or Queens. And the last part is model selection. So our goal is to find a model to predict the duration of each trip using the training data. So naturally, our outcome variable is trip duration. but we made some modifications to the predictors, and the predictors include distance, and we calculate the distance from the 4 coordinates using the Python package Haversine. And we also have the month, day, week, and hour variables from the pickup time, because we believe like each like the month, day, week, or hour, they have like they have the impact of the trip duration. So we use 6 models were evaluated here. We have k-nearest neighbor regression tree, random forest, XGBoost regression, rigid lasso, and we use we implement tenfold cross validation here, and the average values of each model's RMSE, they are listed in the figure here, and from the figure we can see that random forest and the XGBoost regression, they have the lowest RMSE of the among all 6 models, and thus they are the better models. And yeah, so basically that's it. I hope you guys enjoy it. Thank you.
Okay, thank you very much. Thank you for the presentation, and that's invite probably today's last group, group 12, Fan Yanjie and Lan Yingxing. Yeah, please.
I'm sorry. I'm just still trying to share my screen.
Yeah, please.
Sorry.
Yeah, I can see it.
Okay.
Yeah, please go ahead.
Okay, so good afternoon, everyone. My name is Fan Yanjie, and today our group is going to present our group project, the traffic peak forecasting. First, like my group member Lan Yingxing to introduce you guys about the project.
Hello everyone, my name is Yingxing Lan. First, let me introduce our background. So nowadays, as the development of technology, more and more countries are going to build smart cities. Smart city has a very large range, which includes the business, transportation, environment, government, people, and so on. But in our project, we're gonna focus on the traffic. What we want to do is to build a traffic model so that it can help us prepare for the traffic peak through prediction. We use a data set from Kaggle. It has 4 attributes: date, time, junction, vehicles, and ID. Date time records time by hour in 20 months from 2015 to 2017. And the junction shows the junction type. Vehicles records the number of vehicles. ID is just another format to record the date time. Our data set is separated into 2 parts, training set and test set. So how we going to analyze the data is, first, we perform the exploratory data analysis. Then we select and create suitable features. After that, we did some data encoding. And finally, we train some machine learning models to find the best fit models. Now let's see about the exploratory data analysis. As we can see from the table, date time is a date accurate to hour. Junction is an integer between 1, 2, 3, or 4. Vehicles is also integer, which represents the number of vehicles, and ID is also an integer. Now we check if there is any value we need to deal with. First, we check about the missing value. As we can see from the summary table, all of these 4 attributes doesn't have any missing values, so we have nothing to do in this part. Then let's focus on the duplication values. As we can see from the previous table, the ID and the date time are values, have values that are all unique. So we don't need to worry about these 2. But vehicles and junction, it has not unique value. So we need to consider about these 2 attributes. However, when we check about the meaning of these 2 attributes, we see that junction represents the type and vehicles records the number. So they are both reasonable to have duplicate values. We don't need to remove this part. We also check about the outliers. Outliers here are some large values, but since they are not caused by any measurement error or recording error, and they are all reasonable, so we don't need to remove the outliers. Now let's focus on our targets, the vehicles. As we can see from these 2 plots, most of the values are located between 0 to 50, but there are also a few numbers that over 150. Then we check the relationship between vehicles and other attributes. First, let's look at the left plot. It's clear that there are some patterns between time and the number of vehicles. So this notices that there may be some relationship between time and the number of vehicles. The right plot shows that if the junction type is 2 or 4, the number of vehicles is located between 0 to 50. But when the junction type is 1 or 3, there may be some values over 100. Now, my teammate Yinjie will introduce the following steps.
So as my teammate mentioned before, so for this project, we are more focusing on the attribute, the date time. As the information mentioned before, our data is from 2015 November to 2017 June, where we wanted to use this period data to predict the number of the vehicle from the 2017 July to the October. So first thing, as we wanted to predict the 4 months, so we select some data and we drop some data. For example, we drop the data in 2015, which is record the data from November to December, as we wanted to predict the data from July to October. And as we first select the data, and next we do the feature creation. As mentioned before, we wanted it is clearly the relationship between the junction type and the number of the vehicle. So here we wanted to more focus on the track on the relationship between the date time and the number of the vehicle. So here, to deal with the this attribute, first of all, we wanted to format this attribute as the type which is recording this data, it was object. So first thing we want to do to format the data, we transform the data type from the object to the numerical data, which is the date time as a numerical to storing the data. And next, as we wanted to discover the relationship between the time and the number of the vehicle, so we wanted to create as different features as possible. So here we create different features like months, day, year, even specifically to the week, the quarter, the hour, as shown before. And as we can see, the majority attributes are categorical data. So as we wanted to further analyze the relationship between these 2 attributes, we have to transfer the categorical data into the numerical data. So the next thing we do is the data encoding. We use one of the most popular way to do it, or the one-hot encoding, to create a dummy. So as you can see here, we separate each
each type into individual the attribute here. And here is the preview of the attributes that were created. We separate each the month, the weekday, the quarter, and the day. As we mentioned before, the background is we wanted to investigate the relationship between the time and the number of the vehicle. As the time we do the feature creation, so which is the categorical data. In order to deal with this large data set with lots of the categorical data, so we choose the gradient model. And in another way, as the data set which has a lot of the training set, as I mentioned before, the time is recording orally. So there's a lot of data, and the number of the features is relatively small, and thus based on the consideration of the efficiency and accuracy, we choose the gradient boosting. As the parameter or setting here, or at the default, we set the max steps as 6 and didn't change the learning rate and number of the tree and etc. Setting, and we set the metric as we wanted to see the mean square deviation as small as possible. So we turn the parameter for the best result as we separate the data into training and validation set. As in order to get the best fit model, we adjust some of the parameters. For example, we set the learning set to the 0.001 and change the number of the tree in order to avoid overfitting, and also want to try to fit as more possible. And another discovery is we found that the hour and weekday is quite important feature to affect the number of the vehicle, which is quite reasonable, as in every day in the rush hours, there's a lot of the traffic, and it may cause a traffic peak. And that's our final model to predict the number of the vehicle. And more details about the more specific number of the parameters because of the huge page we didn't attach here, but we attached in the project. So, and that's our reference list about the project and the figure, and that's all. Thank you for listening.
Thank you very much. Very nice time control and good report. So thank you for. Okay. All right. So thank you for all the group making presentation today. I got a lot, and I guess you guys also paid a lot of efforts. So due to time limits, we will stop here for this week. And next week, we will start with group 13. Okay, then to finish the presentation, and also I will spend probably half an hour or 40 minutes to do the final exam review. All right, so I will see you guys next week. Okay, bye-bye. Have a nice night.